and yesterday we talked about completing the square and the importance of completing the square. When we are trying to find the maximum or minimum of a function, we have a couple of methods that we can use. Now, we spoke in class about why the factored form of a function is a good place to start, both in graphing it and finding the vertex form. The factored form of a function allows us to find the x-intercept and allows us to get a feel for what the function will look like on a graph. But if a function does not have x-intercepts, meaning that its discriminant is negative and it will never touch the x-axis, or in very hard situations where the function is not easily factorable, we do have another skill or another tool in our bag of tools, which we call completing the square and taking a function from standard form to vertex form. And the vertex form of a function is y equals a x minus b squared plus q. Now, in my function over here, a equals 1 and b equals 6. And I'm going to stop this exercise for a second to first remind ourselves what is a perfect square. So let's see what is a perfect square. What if I take x plus 5 squared? Now, you do remember, hopefully, that we've done lots of patterns in that first unit in polynomials, and I kept asking you to remember the patterns if you can. But let's say that you do not remember the patterns. The other option that we have is multiplying the bracket by itself. So x plus 5 times x plus 5. Now, hopefully we do know how to do that because we do apply FOIL. And it would be x squared plus 5x plus 5x plus 5 times 5 can be written as 25 or 5 squared. And I want to keep it kind of consistent between the first term and the last term, so I'm going to write it as 5 squared. Now, the middle terms are alike, so we can combine them, we can group them. So we have x squared plus 10x plus 5 squared. So my x plus 5 squared is expanded into x squared plus 10x plus 5 squared. Now, I want you to take a look at the bracket and the expanded form. In the bracket, we have two terms, right? The x and the 5. In the expanded form, I have 3 terms. So always a perfect square will expand into 3 terms. So I'm going from a bracket with 2 terms into 3 terms. The other thing that I want you to pay attention to is the relationship between b and c. I'm hoping that you can notice that under that square, what's under that square or square root of c is half of b. So 5 equals 10 over 2. Or, if I would say, is that c squared, as it's squared, is b over 2 squared. And I really want you to keep this in mind when we're going to try and complete the square for the function given over here. Now let's go back to our function. My function is y equals x squared plus 6x. Now, I don't have any number after that. There is nothing else provided. And I have to think, what else could I add to my expression to make it look like a perfect square? Well, if I would apply what we wrote in red over here, I can write x squared plus 6x. Now, half of 6 is 3, so I can add 3 squared. Now, can I stop here and just create my perfect square, or do I have to take care of one more thing? Well, let's review both expressions. Are they the same, or did I just change my function to create that perfect square. And I'm hoping that you can see that I've just added 3 squared or 9, which increases the value of my function. If I would have a scale, and on one side I have x squared plus 6x, and on the other side I have x squared plus 6x. If I'm adding 6 next to it, if I'm adding 9, so plus 9, my whole function becomes heavier all of a sudden, right? So it's going to weigh more than what I have on the right-hand side. So my scale would be unbalanced because it's over here now. It's heavier. I'm adding things to it. Now, how can I make it go back up? I need it to be the same as what I've had before. Well, imagine making a 0 out of numbers, right? How can I make a 0 with using 9? Well, 9 minus what makes 0? What cancels this positive 9 out? And hopefully you realize that it is negative 9. 9 minus 9 makes it a 0, which moves my function back up here and makes them equal. So if I add something to my expression, I have to subtract it as well. Now let's look back at our perfect square. How many terms did the perfect square have in its expanded form? Let's count them. 1, 2, 3 terms. I have 1, 2, 3 terms, and I have to stop. So the first 3 terms will squeeze into a bracket, into 2 terms, and then I am left with my 3 squared, which is 9. Now let's see what is squeezed inside into. Well, square root of x, the square root of x is x. Square root of 3 squared or square root of 9 is 3, and the middle term's coefficient dictates the sign, which means I have x plus 3 squared. And the vertex form of that function is x plus 3 squared minus 9. Now, if I look at the vertex will be p is negative 3 and negative 9. I'm hoping that you can find the analogy between expanding and simplifying a perfect square and completing the square useful to keep reminding yourself of, first of all, how many terms do I have when I expand the perfect square, and into how many terms does the perfect square get simplified, and also the relationship between the b, or the coefficient of the x term, and the c is. That relationship is extremely important for your ability to complete the square. Let's try one more example where my relationship is not as simple as this one. So let's say that I have y equals 2x squared plus 16x minus 5. Now, in class, we discussed that this negative 5 is not really useful to us right now. It's kind of a thing that's going to interrupt my creation of that perfect square. So I want you to think as boxing it and parking it. We're going to park it. But it's a very special type of parking. We're going to park it, and at the same time, copied every single line we write. But we're not going to touch it right now. We're not even going to look at it. So let's see what we can do with our function over here. In the example above, we had a equal 1. So it was very easy to create a perfect square. And in my vertex form of the function a x minus b squared plus q, a is on the outside of the bracket. So I need that x squared isolated by itself. So what I want you to do whenever the a is not 1, I want to factor out the a out of the x terms. Not the 5, not whatever number it is out here, you're going to leave it alone. So let's factor the a out. I'm going to write 2 and then brackets And as I said, I'm going to park the negative 5 over here just to make sure I do not forget about it. So 2x squared divided by 2, I'm left with x squared plus 8x. Now, we are starting to see something inside the bracket that resembled our previous exercise. So let's see how we can create that perfect square. I have my a, which is 2, and my bracket x squared plus 8x. Now, we're going to create that perfect square inside this bracket, not outside, because it's not really helping me outside. I have to do it inside of the bracket. So I want you to imagine that you're going to push this bracket towards the negative 5 and fill it in with the number that we need to add and subtract. So let's think about what we need to add and subtract to make my perfect square. Well, the b inside the bracket is 8. So b equals 8. So b over 2 is 4. 4 squared is 16. So I'm going to add a 16 and subtract a 16. Now, inside the bracket, those first 3 terms will be able to be squeezed back into a perfect square. And I highly recommend you use different brackets to keep track of your order of operations. So I'm going to use a square bracket, and then immediately I know I'm going to form a perfect square. So I have x, the middle term decides to sign, plus, and the square root of 16 is 4, or that b over 2 gets put in the bracket, minus 16, I'm going to close my square bracket, minus 5. And today I had a great question in class asking me, Ms. Stoika, why do I have to multiply the 2 with the x plus 4 squared as a whole and not expand it and get rid of those brackets? Like, why do I have to keep that as a whole? Well, let's look at my vertex form. The a is multiplied with the entire bracket. I want you to think of this perfect square inside the square brackets as a block that you can't break. It's a cement block that we can break, we can take apart. It's really what we've been trying to accomplish this whole exercise. We don't want to disturb it, we don't want to take it apart, but I am going to multiply the 2 with each one of these blocks inside the bracket, with the x plus 4 squared and with the negative 16. So let's see what we have. We have y equals 2 times x plus 4 squared. Now 2, positive 2 times the negative number gives me negative 32 minus 5. And now we can group like terms again. So y equals 2x plus 4 squared minus 37. I hope you're finding this video lesson useful in your homework, and I highly suggest that you try and do a couple of exercises on your own at home. If you find yourself in trouble, go back to the beginning of the video and review the fundamentals. Once you have those, you'll find it easier and easier to complete the square.